Hot cognition simply means that the way of thinking that is influenced or affected by our emotional state. So, hot cognition is cognition colored by emotion, and it contrasts with cold cognition, which implies cognitive processing of information that is independent of emotional involvement. So, if your if your way of thinking affected or colored influenced by your emotional state, this is hot cognition. But if it is independent of emotional involvement, this is referred to as cold cognition, and this is the difference between hot cognition and the cold cognition. Theory of mind, because in theory of mind you have to take into account the others emotions, the desires, the thoughts, and you have to attribute some mental and psychological states. It is referred to as theory of mind is included in hot cognition but not in cold cognition. While we are talking about cognition and the cognitive abilities, it is usually said cognitive style or thinking style. What do we mean by cognitive style or thinking style, which is referred to also as thinking style? Cognitive style is a person's characteristic mode of perceiving, thinking, remembering, and problem solving. It is a way of thinking, it is a style of thinking. So, in cognitive styles, they might be or may be differ in preferred elements or activities. For example, some of us prefer visual versus auditory, prefer visual manipulation versus auditory manipulation, or verbal data versus non-verbal data. This is the way of our thinking, the way that we prefer in dealing with the activities or in dealing with the situation. Also, our cognitive style or thinking style affects or influence our teaching style. So usually we learn in the way that we prefer as a cognitive as our own cognitive style. The question now is, let us know some, or the issue now is, let us know some about examples of cognitive style. We have different cognitive style. One of them is referred to as field independent, field dependent versus field independent. Field independence is marked by the ability to separate details from context. If you would be able to separate different details from this context you are dealing with, in that case you are characterized by one cognitive style is referred to as field independence. But if you cannot do, in that case, you are field dependent. A second type of examples of cognitive styles, it is referred to as reflection versus impulsivity. Who display reflectivity in their learning consider alternative solutions. They have to consider different solutions and alternative solutions. But who display impulsivity and spontaneously responding to a problem, are spontaneously responding to a problem with little thought of the various possible solutions and their outcome. A different type of examples of cognitive style, it is referred to as leveling versus sharpening. You have to know that studies revealed that sharpeners are more accurate in the information they are learning at present. Who apply to level to their learning apply numerous memories and prior knowledge to organize new information, but who lean towards sharpening depend on fewer memories to assimilate information. One more example of the cognitive style is scanning. Whatever relevant or irrelevant to the information to be learned, scanners direct their attention to all features of their environment without scanning this, without filtering this information. Okay, so they direct their attention to all features, either relevant or irrelevant. They have a broader view of a problem. But this may be, in some cases, may be distractible. Serialist versus holist. Serialist learners, serialist learners learn linearly in a sequential manner. So they prefer the sequential processing. They prefer structure teaching, while holists work spontaneously, so they depend mainly in spontaneous processing, in holistic processing. To process information, holists don't need structure. They are also able to think broadly about a subject. Among the other key concepts that related to intelligence and the definition of intelligence, that is which is referred to as intuition or intuitive thinking. What is the meaning of intuition? It is the ability to understand something immediately without the need for conscious reasoning.
Hi everyone, it's Yanis here, and in this video we will explore what is cognition. Your highest brain functions operate subconsciously, but they are important and you need to make sure that you nurture them. If this is your first time on this channel, then make sure you subscribe and hit the bell icon to get updates on my latest videos about time management and productivity. Cognition refers to the mental process of acquiring knowledge and understanding through thought, experiences, and senses. These cognitive processes include attention, thinking, the formation of knowledge, remembering, judging, and problem solving. These are higher level functions of the brain and encompass language, imagination, perception, and planning. Cognitive processes affect every aspect of life, from studies to work to relationships. Some specific uses of these cognitive processes include the following. First, learning. Learning requires you to take in new information and combine with existing information to form new concepts and understanding. Second, forming memories. How we remember, what we remember, and what we forget reveal a great deal about how the cognitive processes operate. Third, decision making. Whenever you're making a decision, you have to evaluate the information that you have and judge it based on your knowledge. Our cognitive abilities are extremely important as they impact how we perceive the world, form impressions, and interact with our environment. That's why you have to nurture your cognitive abilities. Here are some tips on how to do that. First, stay healthy. These are the basic human needs: exercising, eating healthy foods for most of the time, and having a good sleep. Second, reduce stress. Stress has a negative impact on your brain function, and therefore it is important to avoid it. Plan your time accordingly so you don't have to stress about uncompleted things. Third, keep learning. To exercise and develop your cognitive functions, you have to consume new information, so make sure that you keep learning new things. I hope that you enjoyed this video and I was able to give you a quick summary on what cognition is, why it's important, and how you can look after it. If you enjoyed this video, I would really appreciate if you could press the like button, as this will help the video reach more people and spread the message.
In my way to finish this lecture, in which we covered some key related and overlapped concepts which that are related to human intelligence, and they are involved in the definition of human intelligence, and we can consider them parts of the human intelligence. In my way to finish this lecture, I would like to give you some about two main concepts or issues that I think they are very important to the connection, to understand the connection or to understand the relation between human intelligence and artificial intelligence. In issue number one, I would like give you some or brief information about the theory. It is referred to as a computational theory of mind. It is not the theory of mind that mentioned before, but it is referred to as computational theory of mind, and also it is referred to as a representational theory of mind. What is the meaning of computational theory of mind? It postulates that the functioning of the human mind is similar to that of a computer. So the brain being the hardware of the information processing system. So as in a computer we have inputs, outputs, and in between we have processing, electronic processing, but in a human being we have also inputs. These inputs are the stimuli around you that hit you, and you have outcome. It is your responses, including emotional responses, intellectual responses, motor responses, any kind of response, even physical or physiological responses. So you have input, stimuli, and you have reactions or responses. They are the outputs, input and output. And in between, we have a processing or information processing system, and the brain is the hardware of this information processing. This theory combines the explanation of how we reason and how mental states work, and is also known as the representational theory of mind. The second issue I would like to highlight now related to computer vision. What do we mean by computer vision? It is a field of artificial intelligence that trains computers to interpret and understand the visual world.
Human vision is amazingly beautiful and complex. It all started billions of years ago, where small organisms developed a mutation that made them sensitive to light. Fast forward to today, and there's an abundance of life on the planet which all have very similar visual systems. They include eyes for capturing light, receptors in the brain for accessing it, and a visual cortex for processing it. Genetically engineered and balanced pieces of a system which help us do things as simple as appreciating a sunrise. But this is really just the beginning. In the past 30 years, we've made even more strides to extending this amazing visual ability not just to ourselves, but to machines as well. The first type of photographic camera was invented around 1816, where a small box held a piece of paper coated with silver chloride. When the shutter was open, the silver chloride would darken where it was exposed to light. Now, 200 years later, we have much more advanced versions of the system that can capture photos right into digital form. So we've been able to closely mimic how the human eye can capture light and color. But it's turning out that that was the easy part. Understanding what's in the photo is much more difficult. Consider this picture. My human brain can look at it and immediately know that it's a flower. Our brains are cheating since we've got a couple million years worth of evolutionary context to help immediately understand what this is. But a computer doesn't have that same advantage. To an algorithm, the image looks like this. Just a massive array of integer values, which represent intensities across the color spectrum. There's no context here, just a massive pile of data. It turns out that the context is the crux of getting algorithms to understand image content in the same way that the human brain does. And to make this work, we use an algorithm very similar to how the human brain operates, using machine learning. Machine learning allows us to effectively train the context for a dataset, so that an algorithm can understand what all those numbers in a specific organization actually represent. And what if we have images that are difficult for a human to classify? Can machine learning achieve better accuracy? For example, let's take a look at these images of sheepdogs and mops, where it's pretty hard even for us to differentiate between the two. With the machine learning model, we can take a bunch of images of sheepdogs and mops, and as long as we feed it enough data, it will eventually be able to properly tell the difference between the two. Computer vision is taking on increasingly complex challenges and is seeing accuracy that rivals humans performing the same image recognition task. But like humans, these models aren't perfect. They do sometimes make mistakes. The specific type of neural network that accomplishes this is called a convolutional neural network, or CNN. CNNs work by breaking an image down into smaller groups of pixels called a filter. Each filter is a matrix of pixels, and the network does a series of calculations on these pixels, comparing them against pixels in the specific patterns the network is looking for. In the first layer of a CNN, it is able to detect high-level patterns like rough edges and curves. As the network performs more convolutions, it can begin to identify specific objects like faces and animals. How does a CNN know what to look for, and if its prediction is accurate? This is done through a large amount of labeled training data. When the CNN starts, all of the filter values are randomized. As a result, its initial predictions make little sense. Each time the CNN makes a prediction against labeled data, it uses an error function to compare how close its prediction was to the image's actual label. Based on this error, or loss function, the CNN updates its filter values and starts the process again. Ideally, each iteration performs with slightly more accuracy. What if instead of analyzing a single image, we want to analyze a video using machine learning? At its core, a video is just a series of image frames. To analyze a video, we can build on our CNN for image analysis. In still images, we can use CNNs to identify features. But when we move to video, things get more difficult, since the items we're identifying might change over time. Or, more likely, there's context between the video frames that's highly important to labeling. For example, if there's a picture of a half-full cardboard box, we might want to label it packing a box or unpacking a box, depending on the frames before and after it. This is where CNNs come up lacking. They can only take into account spatial features, the visual data in an image, but can't handle temporal or time features, how a frame is related to the one before it. To address this issue, we have to take the output of our CNN and feed it into another model which can handle the temporal nature of our videos. This type of model is called a recurrent neural network, or RNN. While a CNN treats groups of pixels independently, an RNN can retain information about what it's already processed and use that in its decision-making. RNNs can handle many types of input and output data. In this example of classifying videos, we train the RNN by passing it a sequence of frame descriptions, empty box, open box, closing box, and finally a label, packing. As the RNN processes each sequence, it uses a loss or error function to compare its predicted output with the correct label. Then it adjusts the weights and processes the sequence again until it achieves a higher accuracy. The challenge with these approaches to image and video models, however, is that the amount of data we need to truly mimic human vision is incredibly large. If we train our model to recognize this picture of a duck, as long as we're given this one picture with this lighting, color, angle, and shape, we can see that it's a duck. But if you change any of that, or even just rotate the duck, the algorithm might not understand what it is anymore. Now, this is the big picture problem. To get an algorithm to truly understand and recognize image content the way the human brain does, you need to feed it incredibly large amounts of data of millions of objects across thousands of angles, all annotated and properly defined. The problem is so big that if you're a small startup or a company lean on funding, there's just no resources available for you to do that. This is why technologies like Google Cloud Vision and video can help. Google digests and filters millions of images and videos to train these APIs. We've trained a network to extract all kinds of data from images and video so that your application doesn't have to. With just one REST API request, we're able to access a powerful pre-trained model that gives us all sorts of metadata. Here's how easy it is to call the Cloud Vision API with curl. I'll send this image to the API, and here's the response we get back. Billions of years since the evolution of our sense of sight, we found that computers are on their way to matching human vision, and it's all available as an API. If you'd like to know more about the Cloud Vision and video APIs, check out their product pages at the links here to see how you can easily add machine learning to your application. Thanks for watching.
As you can figure out now, computer vision is a field of artificial intelligence that aims to train computers to interpret and understand the visual world. And by using these digital images from cameras and videos and deep learning models, machines can accurately identify and classify objects can identify and classify objects and then react to what they see. That's all in this lecture about the related overlap concept which are included in the definition of intelligence. In our next lecture, we will cover some about two main points, two main issues. In point number one, what about the multiple intelligence? Although all of us are intelligent, but we will figure out that we are different in our intelligent behavior. And this is because because there are different or multiple intelligence, and we are differ in this multiple intelligence. And the second topic that will be covered in our next lecture will be about the relationship between information or knowledge, between knowledge, sorry, and intelligence, or definitely knowledge and intelligence. Do we have a relationship between intelligence and knowledge? But now I would like to end this presentation of this lecture by showing you this video. Thank you.
Cognitive skills, aka cognitive functions, are the tools we use to mentally interpret the world around us. Cognitive abilities are brain-based skills supported by specific neuronal networks, which we need to carry out any task from the simplest to the most complex. They have to do with the mechanisms of how we pay attention, interpret, and understand information, remember, learn, analyze, reason, problem solve, and decide what to do. For instance, answering the telephone involves perception, hearing the ringtone, decision-taking, answering or not, motor skill, lifting the receiver, Language skills, talking and understanding language. Attention, remaining focused on what's said. Social skills, interpreting tone of voice and interacting properly with the caller. Memory, remembering what was said in the conversation. And logic and reasoning, analyzing and drawing conclusions from this telephone call. One overarching cognitive skill which affects the other skills categories is known as processing speed. It's the speed at which your brain works when presented with a task or a combination of tasks, despite the presence of outside distractions. This video is courtesy of BrainFit Resorts, where you can learn and adopt a brain-healthy lifestyle to maintain your cognitive skills.